All right, exponential decay functions. Last we talked about the growth functions. Now we're going to talk about the decays. So I left this up here, but on your decay functions, there's a couple things that are slightly different. B is actually going to be less than 1, but greater than 0. So this is our growth. For our decay, B is going to be greater than 0, but less than 1, which means it's going to be a fraction. And I kind of left this up here in hopes that we could kind of compare the two just quickly and to see the difference. So when we talk about decays, we're actually going to be going the opposite direction. So growth means it's going up. A decay means it's going to go down, and I missed the mark. It should cross right here. So let's see if we can clean that up just a little. So the purple is your decay. The B value will be between 0 and 1, but the function itself is still B to the x. Okay, it's just that B is now defined as being greater than 0, less than 1. This right here still holds true. The process in which we're doing, everything is going to stay the same. Our reference points are 0, 1, negative 1, and 1 over B. The asymptote is still y equals k. Our domain, it still goes left and right forever. And our range, in this case for the parent, it's above the y. And so a lot of the things are very, very similar, very much the same as to what we were doing. So we're going to look at a few. Over here, we have g of x equals 3 times 1/2. That's our b value. Remember, it's between 0 and 1. X minus 2 minus 2. Remember, your domain is going to always be the all reals. So our domain, if we start filling this in, x such that x is an element of the reals, x is going to go from negative infinity to positive infinity. Your range, well, it's going to look a little different. So we'll talk about that as we look here. Let's get our asymptote in. Our asymptote is y equals k. Our k value is negative 2. So at negative 2, I've got my asymptote. Let's see if I can move my board down just a little. So here is y equals negative 2, or f of x equals negative 2. That's my asymptote. Now, my reference points are 0, 1, and this should be negative 1, 1 over b. My b value is 1/2, so that's 1 over 1/2, which is really 2. So my reference point here is going to be negative 1, 2, 0, 1. Now, what are we doing to our reference points? Well, I'm stretching it vertically by 3. That means the y value gets multiplied by 3. This here tells me I'm moving it to the right 2, so I'm adding 2 to my x value. And this says I'm going down by 2, so that gets subtracted from the y. So our new points become 0, 1, and for this one we get 1, that's 6 minus 2 is 4. There's our new points. So we're going to graph them. At 0, I'm at 1. At 1, I'm up at 4. And remember, this should be going which direction? It should be going downward. And I think I just graphed 0. What did I do here? Oh, it's not 0, 1, sorry. It's 2, 1. I made a mistake. 2, 1, this way. So remember, it should be going a downhill ski slope, and it's not going to cross our blue line. So it's going to start up here, it's going to go down, and it's going to make that ski slope, like you're going downhill. That helps me fill in my range and my domain. My domain's done. My range, it is greater than the value of negative 2. So y is greater than negative 2. My interval notation, we start with the bottom, negative 2, to positive infinity. Even though I know it talks about us looking backwards, but we go bottom to top. So let's look at another and graph it. Domain, what do you think it's going to be? Think maybe reals? and that means the interval would be negative infinity to positive infinity. The range we can hold off on. The reference points. Negative 1, and it's 1 over b. So 1 over b, that's 1 over, not negative, 1 over 10, which means we flip that over because it's a fraction, and we just get 10 here. Our asymptote is our k value, which is 8. So my graph doesn't quite go big enough. Here is my asymptote. It's not going to cross that. And remember that negative out in the front, that means we're going to flip it over the x-axis. So look at your values. We've got a negative out in front, so that negative 1 is going to get multiplied to the y value. And that 2, this needs to be subtracted from your x, because remember, it's the opposite. And the 8 is going to get added to your y. So we're going to multiply our y's by negative 1 and add 8. And we're going to subtract 2 from our x's. That means I get negative 2, there's negative 1, 7. And for this one, I get negative 3. That's negative 10 plus 8 gives me a negative 2. So we have our points, our reference points, and we're going to graph. So let's see, negative 2, I'm up at 7. Negative 3, I'm down at negative 2. So remember, it flipped it over. So this kind of looks, and these are very hard for me to draw, but it's kind of going down like this. And it has a steep, sharp curve because that 1/10 is pretty sharp. That means our range. Is it above the 8 or is it below? Since it's below, we write it as y such that y is an element of the reals. Y is less than 8. And for our interval, we start at negative infinity at the bottom, and it goes to the absolute max, which has to be less than 8. So this is kind of how we graph. Now let's look at some where we take the graph and we write the equation. So we're moving backwards, moving in the opposite direction. So we're going to write the equation from the function that will produce the given graph given the specified value of b. I think I left that value off here. Nope, we don't get a specified value of b on these. We have to actually find it. So our asymptote, y equals, where's the asymptote? It's at 4. So y equals 4. That means k is 4. We're on a roll. We have 1 out of the 4 values we need. Our reference point 0, 1 went to negative 3, 1. 0, 1, negative 3, 1. That means the h is negative 3. So far, so good. We have 2 out of the 4. To find a and b, we know that whatever we did to a, we're going to multiply that by 1, add the k value, and that's supposed to equal this one. The k value is 4, so a times 1 plus 4 equals 1. That gives me that a is negative 3. So now we're here. F of x equals negative 3 times whatever b is. X minus, what was our h value? Negative 3. Plus our k, which was 4. Be careful of that double negative. We got to change it to a positive, so we get f of x equals negative 3 times something x plus 3 plus 4. Now, remember, this is our b value. We have 3 variables. We have f of x, we have x, and we have b. We can only do this if we have one variable. But we have another point. We have negative 4, negative 2. That means that I can actually plug this in for x, this in for f of x, and solve for the b. So here we go. Negative 2 equals negative 3 times whatever b is. For x, I'm going to put in negative 4 plus 3, and then plus our 4. So first things first, getting that b by itself, we're going to subtract that 4 out. And so I have negative 6 equals negative 3 times b. Negative 4 plus 3 is negative 1. I'm going to divide out my negative 3. So I have 2 equals b to the negative 1. That means this is flipped over. So that's 2 equals 1 over b. Well, to solve for b and get it on top, I flip this one over. So b is 1/2. And here is your function, your final value. b is 1/2 x to the plus 3 plus 4. So we have another one to look at all the way on the other end. See if we can move some space down here. Here's another graph we're going to look at. We've got our asymptote drawn in at -1, so we're going to write that in. So that means that we have our k value. Asymptote's -1, that means k equals -1. The point 0, 0 goes to 2 and -1/2. So all we care about, because this is the reference point, that h value, h equals 2, because we had to add 0 to 2 to get there. 1 times our a value plus k has to equal the -1/2. This is the formula we will use to find our k. So we're going to use this point. 1 times a plus k has to equal that -2. So 1 times a plus k equals -1/2. We know k is -1, so we're going to replace that. Add 1 both sides. So a is equal to positive 1/2. Now we have h, we have a, we have k. So we're going to start with our equation. Now, we have 3 variables. We have g of x, we have b, and we have x. We need to figure out what some of these are. Let's see if I find a better black pen. We're going to use our other point 1, 4. This is your x value. This is your y value, or your g value, g of x. So 4 equals 1/2 b to the 1 minus 2 minus 1. Now, I'm going to add the 1 both sides. It gives me 5 equals 1/2 b to the -1. Multiply both sides by that 2, so I've got 10 equals b to the -1. Now remember, b is supposed to be a fraction, so we should be getting b to the -1 each time. So that's 1 over b equals 10. To find b, I flip it over, so I get 1 over 10 equals b. Going back to our equation right here, we're going to plug that in. b is 1 over 10, move your parentheses. So g of x equals 1/2 times 1 over 10 to the x minus 2 minus 1. And there you have a second equation of finding your function.